Good day, I'm Manuel, and today I want to talk about factoring a trinomial using a method I like to call the swarm method. Not that different from the conventional way, but it's just a clear way of looking at it. And first, I'll just talk a little bit about what is a trinomial. And that is if you take an expression in the form of ax squared plus bx plus c. A lot of equations or expressions you'll find that you can arrange it in this way, and so as long as you can arrange it in this way, it's a trinomial. And factoring a trinomial is basically converting it from an addition problem into a multiplication problem, where it looks something more like this: x plus m times x plus n. And we do that for a number of reasons. It would be easier to solve for x. It's easier to do certain algebraic changes to the expression once we've converted it that way. And so I'll get right on to the idea of how you would factor an equation like this using the swarm method. So let's take that expression again: ax squared plus bx plus c. And we're going to do something called prime factorization, or finding the prime factorial for the a and c variables. And so I'll just write that down. That's prime factorial. And so wherever you see the down arrows, that's what we're doing, a prime factorial. And so because I don't know these variables right now, I'm just going to write I'm just going to put some little arbitrary variables. So we'll call it m's and n's, m1, m2, m3, and then n1, n2, n3, or I could call it a1, a2, a3, I don't know, but okay, so we're going to we're going to swarm these, and also we're going to want to remember what the b, we're going to want to know what the b variable is, but assuming that we know the answer for b and we know the answer for a and c, so basically we know everything except x, this is where we can swarm them together. Okay, so we swarm them, we just take all of those variables, the m's and the n's, together. Doesn't really matter how we arrange them together, they just have to go in the same place. I would normally, you might expect in a typical polynomial, it's going to be like lots of 2's and 3's, maybe some of whatever prime numbers. And I like to put the prime numbers together. That's going to help me see it more clearly. So all the 2's together, all the 3's together, and so on. And so this is like the swarm. And so the basic question is when we're gonna take another subset from this swarm. Let's suppose we just take this subset. We're trying to answer one question, which is let's just label these subsets first. Okay, so now that I made that subset, that's P and this is Q. And the big question is P plus Q equal to B? And so we're gonna do it like a little test. So let's suppose that we calculated this, and this is the multiplications of the variables together. P is m1 times n1, Q is m2 times m3 times n2 times n3, right? Do they equal B? Let's suppose that P, in this case, P plus Q does not equal B. Well, there's two different options. So if yes, if they do equal B, then we go to the next step. But if no, then we redo this step. We redo it in a different way. And so right now we're assuming that they don't equal each other, so we have to redo the step. And where I call this test 1, the next one I'm just going to call it test 2. Now, as you practice this, you might find that you can just do this mentally. You don't have to keep on rewriting your test. You can just do, oh, okay, if the These multiplied together, that's the p value, and these that's the q value. Does that equal b? Oh no, okay, let me think about it different. So if you're able to do it mentally, so much the better, but you can always do it in written form too. So to repeat the test with it, or to reset the test, we're going to do the exact same thing. Of course, we could just M1, M2, M3. See, even in math, we do experiments, right? Just like in science. Okay, so we have them swarm together again. And let's say this time we want our subset where we think that this might work. And M1 times N1 times M2 plus N2 times M3 times N3, right? So that's our p value, this is our q value, and we're asking that same question. Let's suppose that in this case we found out that p plus q does equal b. It worked, okay? What do we do next? So let's go back, let's label this the next step. So this is what we do next. And let's take back that original equation, the ax squared plus bx plus c. Well, now that we know this answer, we can actually convert it into something else. It's not going to be quite the answer we're looking for yet, but it's going to be an intermediary step that'll lead to that. And what we're going to do is we're going to replace that middle term, the bx, with px plus qx. So it's going to look like this. We now know that it's going to be equal to ax squared plus px plus qx plus c. Why do we know that? I'm just going to say magic. I could show you more of a proof for that, but by the powers of magic, ax squared plus bx plus c, once you know that the p and q equal b, it's automatically equal to ax squared plus px plus qx plus c. Okay, so now it gets a little more complicated, but this is almost going to bring us to the last steps. And what we need to find is factors of a and p, factors of q and c. Sometimes you may need to rearrange them. You might find that it looks like it works better if you put the q over here and the p over here, or you switch the two middle terms around. But basically, they are going to factor, because if this is true, then having a common factor for these is also true, which is the point of the whole exercise. So with the factor, we're going to make we're going to invent two new variables I'm going to call y and z. Y is a factor for a and p. Z is a factor for q and c. Okay, and it's going to look more like this. So yx, okay, times ax plus p, because we can now, with the x outside, that's basically this x factored out, ax plus p over y, okay, and then plus c, so our new factor, which is for q and c, that's qx plus c over z. Okay, now it looks complicated, but because those factor, then it's gonna look a lot simpler when you put it all together. So now there's another last step that looks a little bit like magic until you're more familiar with it. One thing we want to make sure is we want to be sure that this statement is true. Ax plus p over y, so this term here, is equal to qx plus c over z. This has to be true before we can go on, and there will be a way. As long as this is true, that p plus q equals b, you're going to find a way in which both of these terms, ax plus p over y and qx plus c over z, are equal to each other. So as soon as you have that, okay, now you're going to do a little bit more magic, and you're going to rewrite the equation as, let's see, it goes y x plus z, and this is going to become its own term, and then you're gonna choose just one of these because they're equal, so it doesn't really matter which one you choose, right? And you can eliminate one of them because it's like factoring out the same number. You no longer need it. It doesn't really give you any new relevant information. So that's yx plus c time, let's just choose the first term, times ax plus p over y. This is actually your final equation. So it looks a little bit more complicated than this one up here, but that's only because we haven't factored the y yet, and because this will be factorable, it'll look more clear. It'll be like yx plus c times ax plus something x plus something. You know, it'll look more clear. And then from there you could always take out the you could factor out one of the first terms, and then make that the denominator for the second term, so that it basically leads you there. So let's start doing a more real example where we know some of the answers for these variables. And so let's say that a equals 6. Let's say that c equals -12. And let's say that b equals 1. What is that going to look like? Well, let's go back to our previous equation. I'm just going to rewrite it over here so that it doesn't, so it looks a little more clear. X plus b, x plus c. Okay, and plugging in these variables, that's 6x squared plus x, because we don't have to write the 1 if it's just 1 there, and then minus 12, because we don't have to write the plus if it's plus -12, right? Okay, so what's the first thing we do is prime factorial for a and c. So that's this one. What's the prime factorial of 6? That's 3 and 2. 2 times 2 is 6. And for the -12, a little more complicated, but first let's factor out the -1. Easier to work with a positive number. And we know that 12 divided by 2 is equal to 6, and 2 is a prime. So we could factor out the 2, and then we have a 6, which of course we just put another 3 and 2. Okay, so that's the prime factorial of 6 and -12 put together. So we could have actually found the common. We could have found out what 6 times -12 is equal to, but it's not actually necessary. We just find the prime factorization of both, and then we're set. So let's put these together. We'll swarm them, and it's basically 3 2s, 2 3s, and a -1. And as I said, I like to put them together. So I've got 2 3s, 3 2s, and a -1. Okay, that's our swarm. And let's say for test 1, we want, here, whole new kind of problem. We figure maybe this is going to be our answer. Maybe this time, this multiplied plus this multiplied is going to equal 1. Is it going to equal 1? Let's see. So 3 times 2 is 6. We don't have to write it as a p-value right now. 2 times 2 is 4, times 3 is 12, that's -12. Oh, it turns out we got our same values. But does 6 plus -12, or 6 minus 12, does that equal 1? No, it doesn't. It equals 6, right? So in this case, 6 minus 12 does not equal 1, because at this point we actually don't care what else it equals to, as long as it doesn't equal 1. That just means we go back. So the same way, if this doesn't equal, here I'll put the question mark there. If they don't equal, then we have to redo this step, right? So let's do test 2, and same swarm. We don't have to change anything, but now let's subset this corner here. Let's make this a 9. And this makes this other side for 8, -8. Okay, And so again, we're asking the question, 9 minus 8, does that equal 1? Yes, it does, actually. So we can start writing that. 9 minus 8 equals 1. And so now it's yes, p plus q does equal b. And so we can go to the next step. And let's just add these variables too. So p is equal to 9. We didn't bother with the p here because it was a failed test. Q is equal to negative 8. Okay, so now we have to rewrite the equation. We're at the next step, ax squared plus bx plus c. So let's just rewrite that equation that we originally had, 6x squared plus x minus 12. And now we have to rewrite that as ax squared plus bx plus qx plus c. And now we can just start plugging in values, right? So a is 6, we don't know x yet, x squared plus, but we know, of course we know b is 1, that's, but we're converting it, so we ignore b now. P equals 9. Okay, so 9x minus, because q is a negative, minus 8x, and then c stays the same, minus 12. Okay, so those are equal, and it apparently does. Yeah, they're equal, right? We know that. But the bonus of changing this is now we know that these factor together. 9 and 6 factor by 3, and we know that negative 8 and negative 12 factor by 4. So let's use that for our y and z values. So for y, for now we're going to do 3, and for z, that's going to equal negative 4. And we also have to make sure this is a test because they'll both have to be equal. Let's make sure that they're equal. Okay, so let's rewrite that. So now we have to write out this equation. Okay, so 3x times ax plus p, so that's 6x plus 9 over y, so 3. Okay, plus, and z, or actually we don't have to put, it's just minus 4. And that's times qx plus c, so that's negative 8x minus 12. And again, over negative 4. Okay. Qx plus c over z. Oops, sorry. We're over here. We made it up to this part. Okay, and notice we can simplify. So that let's do some simplification before we move on. Okay, so 3x times 2x plus 3. So we can get rid of the denominator altogether. Minus 4 times 2x plus 3, because that's divided by negative 4. 2x plus 3. Okay, so those are equal. And wouldn't you know it, 2x plus 3, well, is obviously equal to 2x plus 3. They're the same term, right? So we're now ready for the next step. Okay. And we're almost there. See, we've done those steps. So 3x minus 4. So now a little bit of algebra magic. We do 3x. We'll say that's equal 3x minus 4. Right, that's our yx plus c, times, and then we can just choose the first term because it doesn't, they're the same, it doesn't matter, times 2x plus 3. And so that's the same as ax plus b over y. They've factored, right? Okay, so that looks very similar, right? 3x minus 4 times 2x plus 3 looks a lot like x plus m times x plus n. The only difference, like, because it looks like they work out to be fractions, like you can do x minus 4 over 3, x plus 3 over 2. They'll never really simplify to more than that, but that's manageable. So this is the answer using this system. All right, thank you.